I'm Simon the Scientist, and happy the day after Easter. And I don't know when I am going to use some of my Easter treats to explain something in this I forget what it's called.
Like a session?
Yeah. And I may be having a bit of weird in it.
You have a weird day today?
Yeah.
Well, weird days are good. We're talking about one of our very favorite things today. What is it?
Astronomy.
Mm-hmm.
It's 25% one of my favorite things about science.
25%? What are the other ones?
The other 25% is chemistry.
Mm-hmm.
And there's a 10% of technology.
Mm-hmm.
10% of wait, no. It was 20% of physics. Oh yeah, technology and physics go together.
Well, they all go together in some ways.
Yeah.
Yeah, everything's connected, isn't it?
Yeah.
All right. So we have RJ that said Happy Easter, Simon. Parker, Vince, and Wendy are watching, and they said Hoppy Easter.
Wait. Can I?
Oh, 1 second. Yeah, sorry, we had a bit of a pause there. Okay, so let's get back to astronomy. You have a couple things to share with us, don't you?
I have a snappy toy.
Not the ruler, hang on. You have a couple things right here.
What's an astronomy's favorite movie?
Do you want to wait for people to answer, or do you want to tell them right away?
I'll wait for people to guess.
Okay, we'll give it a few seconds. What is astronomy's favorite movie? Okay, so while they put in their answers, you can tell us.
It is Astronomy.
So the movie...
Tron.
You bet. We have Belle and Brady are watching as well. Okay, do you have another joke?
Yeah.
Okay, what?
Why did the star get arrested?
I don't know. Why did the star get arrested?
It was a shooting star.
Good one. Elisa and Lucy, Edward, and Chris say hi. Oh, Parker had a good one too. Astronomy's favorite movie? A Star is Born.
I know that one.
Yeah, good one.
I've seen a commercial.
Yeah. Okay. Another joke? Want me to tell it to you?
Yeah, okay.
And you can say the answer?
Yeah, okay.
What do you do when a baby astronaut is crying?
You rock it.
Good one. Oh, we have another answer for astronomy's favorite movie.
Okay, what is it?
Star Wars. Good one.
That could have been a different answer for why did the star get arrested. It was in a Star War.
Yeah, that could have been as well. All right, we've got one last one here for you.
What's in the center of Jupiter? This might be a hard one.
We'll give everyone a moment to type in their answers.
Probably double the time of a usual one for them to figure it out.
Okay. All right, are you ready to say the response? What is in the center of Jupiter?
I want to give them a little bit longer because this one's actually hard.
This one is hard. So we'll let people have a moment to answer that riddle. What is in the center of Jupiter? And while we're doing that, you have something here to show everyone.
book.
Tell us about your book.
Space book.
Okay. When did you get this book?
When I was little.
When you were little. What do you like about this book?
That it teaches about space.
Mm-hmm.
And I actually forgot about this book for a while. And I decided about astronomy because I remembered about this book and I wanted to see it again.
Yeah.
Hey.
Do you have any favorite parts or pages of the book to show?
I'm gonna find it. I don't know for sure though. Oh, it's actually the first page. I forgot that it was the first page.
Ooh, this is a very cool image.
Nebula.
Mm-hmm. What's nebula?
It's an exploded star that makes new stars.
So nebula is the dust and gas.
Yeah.
Yeah, that's right.
Hydrogen and helium.
What about hydrogen and helium?
That's what the star is made of, and that's why it looks like all the smoke.
Very interesting.
All this galactic space smoke.
Yes, galactic space smoke. So we have a couple answers here. We have a couple guesses of what is in the center of Jupiter. We have dust, lava, another guess of dust, and Christine said the letter I.
Yep, you're right. Because Jupiter.
That's right. Letter I in the center of Jupiter. Oh, and guess what Elisa says?
What?
That she likes your acorn. Because who showed you how to make that?
Elisa.
That's right. That's pretty cool. Okay, so you had a couple things that you wanted to talk about, some of your favorite astronomy topics that you wanted to talk about. But before we get started, we want to tell everyone who's watching to tell us your favorite parts about astronomy and what you like to talk about or what you're curious about. So what's your list there?
I don't know about this fact for sure, but I believe it's true. If we can travel to a black hole, we can get close enough, and if we can get close enough that it still makes us spin because black holes are spinning, and while it's spinning, the rocket is gaining energy. So while you're spinning, you can take photos or pictures of the black hole while spinning. Then you can use the black hole's energy from when you're spinning to go back.
Interesting. Do you want to demonstrate what you mean?
See, this is a black hole.
Well, you've also got these to use.
See, this little piece of granite, a black hole.
Okay.
And this, the rocket.
What is that?
A Easter tree.
Yep.
So it's like this. The rocket is using the black hole's energy. Oh, it'd be better if I just draw it.
Okay.
Then after you're done, zoom.
So where does the energy in the black hole come from? Because wouldn't you get sucked in?
I said was, and like at least enough that you still spin but not get sucked in. Because black holes spin.
Yeah.
It's just a collapsed core.
Right? That's right. So you have to be in just the right spot for that to work. Right on. What else did you want to talk about?
Stars and what they can become.
Like a celebrity?
Yeah. But I am going to talk about a planet that I think may support some life in the future.
Okay.
It's located like around 600,000 light years or so away from us. But so it is said to be full, like it's like a flooded planet. just full of water.
Mm-hmm.
But it has no life yet. And it is cold. But if we manage to get there in the late future, we could create a new planet to host life after our sun explodes.
Oh,
So
yeah.
we can live longer and evolve.
Yeah. Well, that's something that astronomers and astrophysicists are really thinking of, is where else could we live if we couldn't live on Earth, if there was an emergency that happened.
Like a rogue solar system crashing into ours, or a rogue black hole coming into our solar system.
Yeah. So those things are incredibly unlikely.
Yes.
But
they could still happen.
Yeah, I guess it could. Or if there's an emergency on Earth and we needed to go live somewhere else, where could we go?
Like if there was a worldwide asteroid shower.
Something. Yeah, that's right. Things that haven't really happened yet, but they could happen. Hey, what else did you want to talk about?
Okay, back to stars and what they can become into. Stars can become black holes, but I'm not going to talk about this again.
Okay.
They can also become supernova, but our sun will not become a black hole.
Why?
It will become then a white dwarf, then a black dwarf, then a black hole. So we might still have a chance of living, but the sun might get smaller.
So what determines what happens to a star after star death?
So a superstar, as in like a really giant star, will become a black hole or a supernova. But our sun is like a medium star, not big enough to become a black hole.
So what are the determining factors for what a star becomes?
A star can either become supernova.
No, what determines, like, what makes the decision of what it can become?
Its gravitational force, its weight, and its heat.
Yeah, those are all parts of it. You bet.
So each level of every one of those matters of its size, shape, and color.
Why color? What does color on a star indicate?
Like this. Blue stars are the hottest. White stars are the oldest.
Not oldest.
Coldest. Wait, no, not cold.
White and blue are kind of at the top of the range.
Yeah.
Yeah. So color determines.
And red is the coolest.
There you go. Yeah.
Not like, I'm a cool kid now. Cool.
That's right. Okay, so everyone, make sure you tell us what your favorite things to talk about with astronomy are as well. So Simon, I have 2 activities to show everyone, and you did not do these ahead of time, did you? So we have in front of you a pencil, a paper, and a ruler.
Actually, 3 papers.
Yeah. So this is the activity that we would like you guys to do at home.
Why didn't you tell me? I asked you to tell me.
I did not want to tell you because I wanted you to do it for the first time here. So what I have here is from a website called Wild About There.
Exoplanets.
I'm going to post pictures of these for all of you on the comments to this video. And this is what the diameter of each planet would be as a scale representation in centimeters. Okay, so if you want more information about this activity, you can go to Wild About There. But this is what we are doing. So Mercury, Simon, would have a diameter of 0.8 centimeters. So can you draw Mercury? 0.8.
Yeah.
That means it's less than 1.
Right about there.
Okay, so draw a little line to there.
There.
Oh, but you have to start at the 0 and then finish at the 0.8.
I did 0.8.
Yeah, we're not just measuring, we're drawing the line. No, I'm going to show you. So this is a good math activity as well. So when we measure, we start the line at 0 and then we draw to 0.8. So that's your diameter. And because it's a diameter,
I never knew Mercury was so small.
We can draw a circle around it.
I never knew Mercury was so small.
Mercury is so small. Now,
Like,
we should label this.
Mercury with only 2 fingers. It's that small.
That's right. So you should label this with an M for Mercury. And then I'll show you the comparison of how big Venus is to Mercury.
That's a terrible M.
That's kind of a silly M. It's like an alien M. Okay, now Venus is 1.9 diameter, 1.9 centimeters in diameter.
1.9.
Yeah. So you start your line from the 0 and go to 1.9. There you go. And you draw a circle around it. Okay, and that's how big Venus is in comparison. Isn't that cool? Now, Earth would be 2.0. And its diameter, that means the width of the circle.
No, it's definitely like that, I think.
Okay, and do your circle around it. And that's Earth.
So it'd take 1.5 Venuses to destroy Earth.
Well, I don't know about destroying, but look at Venus and Earth mathematically are just about the same size. And they're both much bigger than
Mercury.
That's right. So when we look at this and when we continue to draw our sizes, you're going to get a really good comparison
Jupiter is
of
22.
the size of planets.
Jupiter's 22.
Yeah.
I feel bad for Mercury.
Well, which one's the smallest
8.
out of all the planets?
8.
It's not 8, it's
8.
0.8. So not even 1.
8.
Yeah. And which one's the biggest?
22.
Good. So
You forgot something.
what's that? 22.0. That is correct. That is true as well. We have some friends talking about their favorite things to do with astronomy. We have one friend who likes to talk about what asteroids are. Do you know anything about asteroids?
Oh, I forgot to do that thing.
What is it? Oh,
What am I?
I don't know, Simon. What are you?
Well, it's very small, but still kind of plump asteroid.
You're a small but plump asteroid? Hurtling through space or what?
Moving in the asteroid belt.
All right, come on back, sweetie.
There.
And we have another friend, Parker's talking about he likes constellations. He can see Orion right from his backyard at night. Do you know any constellations?
Yeah.
Which one do you
Leo
have a
the
favorite?
lion.
Leo, yeah. Leo the lion is a good one. Right on. Okay, so this is one activity. This is part 1 of our challenge.
Yeah. The toilet with the spike. The spiky toilet.
The spiky toilet.
Yeah.
I believe that is...
Like the one where it looked like that.
like it looked like the house almost.
Yeah. It looked like a house with a... It was kind of like a house with a pointy roof, or a toilet with a pointy thing where the handle is.
That's right. It's really cool to check out constellations and see what shapes you can think of yourself that they belong in. Okay, so
now
this is...
on to Mars.
No, we're not going to do it all. We're showing people how it starts, and then I'll post the picture of this so people can do it themselves at home and see if you can create all of the diameters of the planets. And again, I will post this chart for you, but you can also find it at this website called Wild About There. Now that's one way to look at planets, is how big they are. But there's another way to look at planets.
How hot they are.
That's one way. But another way is to look at how far away from the sun they are.
Yeah.
So let's go into the living room here, Simon, and I'm going to show you how to do this activity. And this is going to be from National Geographic. So Simon, can you stand right at the couch? Stand right at the couch. Legs up against the couch there.
Legs up against the couch?
No, silly. Here, turn around, like face this way and go all the way back so you're standing at the couch. So that's your starting point. That's the sun. Mercury would be one step away from the sun. Are you hopping or stepping? It's your choice. There you go. Just make sure that they're the same all the time. So that's where Mercury would be. And look back at your sun, which is the couch. That's how far you are if you're on Mercury.
Wow. I never knew my legs were so big.
Yeah. So
And I never knew my legs were heat resistant.
So that's a good way to talk about scale, because scale means we're doing something much smaller so that we can show what something much bigger is like. Okay, so if you were Venus, you would start at the sun again. And you would be, 2 steps from the sun. 1, 2. Now look back and see how far you are from the sun.
Oh my gosh.
Okay,
Oh,
back to the sun.
I can't believe my feet are still okay.
Yeah. Okay, back to the sun.
Yeah.
Now, Earth would be the equivalent of 2.5 steps from the sun, 2.5.
So this is how big my one step is.
Yeah.
So right here is 2.5.
But you have to do 2 first and then a half. 1, 2, and a half. Good.
Here.
So Venus and Earth aren't that far from each other in terms of our solar system.
Mom.
Yeah.
Here's a question I have about Mars.
Yeah.
It is on the other side of the Goldilocks zone, which is where things totally freeze. But how's it still so hot?
On Mars?
Yeah.
Well, I don't think Mars is hot. I think it has extreme temperature changes from when the sun is, from the side that is facing the sun and the side that is away from the sun.
Mom, it's always all hot.
Well, we'll have to look more into that.
Okay.
Yeah.
And
Okay.
go back.
Yeah, go back and we're going to do one more.
Super sad.
Mars would be the equivalent of 4 steps from the sun. That would be
2.
We have to use the same type of step every time so that it's accurate. 1,
2, 3, 4.
yeah, and look at that. So if you were Mars, look how far you are away from the sun now. Okay, so let's go have a seat here on the couch and I'm going to show you
Bunny rabbit.
the rest of this. Now, it's a good idea if you had something to mark your spots. So if you had a little pebble or a Post-it note or something, Simon, or something,
Or a shoe.
or a shoe, and then you can mark where you end up.
Or a twig.
And look at this. This is the chart of how many steps everything would be away from the sun. And again, I'm going to post this so that everyone can do this activity at home. Now look at some of these.
100 steps.
Yes.
What's the Kuiper belt?
Well, that's the asteroids that are on the other side of our solar system.
Like in the middle of Neptune and Jupiter?
No, after Neptune. And even after Pluto.
No, it's in the middle of Neptune and Pluto. It's in the middle.
Oh, okay.
It separates those two. It separates the two solar systems.
Interesting. And look, there's another asteroid belt here in between Mars and Jupiter as well.
I know.
Yeah, and we even have that information on there. So Our challenge is for everyone to complete their 2 activities. So first to draw the diameters.
Jupiter kind of has rings.
Oh,
Yeah, it does. From asteroids that are heading towards us get caught in its orbit, forming rings.
that happens to quite a few of our planets too. It's
Yeah.
not just Saturn who has rings.
I know.
What did Jupiter say to Saturn? Give me a ring sometime. All right, so to finish up, what's our challenge for everybody, Simon?
Okay.
Well, we're going to ask everyone to finish their steps and to show us how far they get to create a scale of our solar system, and also to do the diameter activity that we just finished and to show us how big their planets will get.
This is the opposite of crisscross applesauce.
All right, so Simon, I think we're done. What would you like to say to everybody?
I would like to say I'm not done yet.
What else would you like to talk about?
I would like to talk about.
Oh, well, we have a friend who has a comment. In 2060, an asteroid will come around the Earth.
It might not.
It might not. What would make it happen or not happen?
Maybe Jupiter will stop it again.
Well, what's so great about Jupiter? How does it have that superpower?
It's like a giant shield for Earth.
A giant shield? How so?
Because it's so big and fat and plump, it covers the way for asteroids to get to Earth. Because usually asteroids go that way, but they're still in Jupiter's and Mars' orbit. So it's like, that.
Interesting.
So they're both kind of like a shield.
Yeah. We have a riddle for you now.
Oh,
What has a bottom at the top?
What has a bottom at the top? Uranus?
I don't know if that's the answer. I'm not too sure what the answer is. We're going to have to wait for Jennifer to tell us the answer. And Elisa's saying, did you see our challenge answer from last time? I don't think we did. I don't think we noticed it.
We never really checked the answers, actually.
Well, I did, but I don't know if I saw that one.
There's a hole in my sock.
All right, Jennifer, we're just waiting for the answer. What has a bottom at the top?
Black hole?
A black hole. What are some other guesses?
Uranus?
Uranus. That's the funniest guess. What else? Any other ideas? It is a riddle.
My mouth is a black hole.
Some days I think it is. The answer is stairs. Stairs has a bottom at the top?
I don't get it.
I'm not too sure either. All right. So Jennifer, you can explain that one to us. That's a very clever riddle, and I love riddles. And we will see everybody Wednesday at 11 a.m. Central.
I just got an idea for a session we already did.
What's that?
It's a technology joke, but not really technology.
Do you want to say the joke now?
Yeah.
Okay.
If a man could build a wall in 1 hour, like a basic wall, like a wall the size of this room, how long would it take for 4 men to build a wall?
How long?
I'm just waiting for them to give their answers.
Okay. So while they type in their answers, now you can say.
Yeah. I'm waiting.
How long?
It would take no time at all because 8 men already built it.
Good one. See you later, everybody. See you on Wednesday.